which I stop here, right there. Point number 3, proton transfer reaction. Well, what we have to study today. Today I'm talking about the identification of the direction of those reactions that are based on the proton transfers. Okay? Well, it means if we have a reaction that contains one proton donor and proton acceptor, and with an identified arrow of the reaction, how we can identify that is reversible or directed? Well, actually here we have something important to know. Proton transfer reactions favor production of weaker product. It means any reactions that base it on the proton transfer, always they produce a weaker product. So always stronger reactant always, okay, go to producing weaker, okay, as I said, stronger to weaker. Please don't forget, stronger to weaker product. Or if we have weaker reactant, they will produce stronger. If we have weaker reactant and we have stronger product, so always the arrows start from stronger, go to weaker. So that means always we have to go from stronger to weaker, always going from stronger to weaker for those reactions that are based on the proton transfer. For that purpose, you have to remember the list of acid and bases with their strength. Actually, it's very important. Hopefully you remember. Well, determine which direction, forward or reverse, is favored in the following reactions. The first one is this. Well, it's strong acid. Okay, because of it releases proton, it's acid, and it gains a proton, it's base. But what type of base? Well, about the strength of water, it depends on the electrolyte that it's come with it. Okay? Look, if water reacts with the strong electrolyte, it will be strong. If water reacts with weak electrolyte, it will be weak also. Because of it's strong, so water is strong also. Strong. Well, and these are conjugates. This one, it produces from the strong base, so it's conjugate. It's conjugate acid. It's acid, right? But because of its origin is strong, it will be weak. I show you how. Look, if we have strong acid, it will produce, okay? You have to write the 100% reverse property of strong acid. It will be weak, strong, it will be weak, okay, base. Weak base. If we have weak acid, it will be strong base. Okay? So weak will be strong, acid will be base. Strong will be weak, acid will be base. Well, I hope you understand this point. I remember you. Okay? Look, if we have proton transfer reaction, I mean if we have a reaction that contains proton transfer, always the direction start from strong to weaker, as I mentioned it here. So now this question is about that note. Okay, I prefer to see these notes with answering of this question so clearly. Look, it's strong acid and it's strong base. Oh, mister, I know it's base and it's acid, but how we know water is strong? Because of it came with a strong electrolyte, right? So it's acid produced from base. It will be weak acid, and its base produced from strong acid. It will be weak base. So the direction always start from strong to weak. So these are strong and these are weak. So it will be forward. So answer is forward. Forward direction. Why? Because of we have two weak and we have two strong. Look, the weak one, the weak acid and strong acid. Which one wins from the releasing proton? Of course, the strong one. Because H3 is weak acid, cannot compete successfully with HClO4, which is strong acid in donation of proton. And we have weak base ClO4, cannot compete strong base, which is water, in accepting of proton. It's strong base. Well, according to this question, water is strong base because of it came with strong acid. Another question, this one. This one, okay, it's good. NH3, we know it's weak base. It produces strong acid. Okay. Because of water came with weak one, so it's weak also. And it's acid. Because of it releases the proton. It's acid but weak one. So weak acid produces strong base. But this time the stronger here and we have weaker here. So the direction always start from stronger to weaker. So it will be reverse, backwards. Reverse direction. Why? Because of H2O, which is weak acid, cannot compete successfully with NH4, which is strong acid, in donating of proton. And NH3, its weak base, cannot compete successfully with OH, which is strong base, in accepting of proton. Well, these are will be your homeworks. I have talked about them many times. So a new thing is amphoteric compound. Okay, amphoteric. Amphoteric is one of again, it's one of the most important concepts to know. So please understand about the amphoteric. Collect all the informations. I'm going to talk about any point that are related to amphoteric. Well, amphoteric, first of all, amphoteric, it's a property. Okay, if anything has this property, it must gain a proton and it must lose a proton. It depends on the type of reaction. For example, hopefully you remember, we have talked about water when we studied Bronsted-Lowry theory. Okay, I said water when reacts with acid, it will be base, accepts a proton, and water when reacts with base, it will act as an acidic, it releases its proton. So water called amphoteric because it can release proton and accept a proton. Look, any species that react as either an acid and base, it means donating proton and here accepting proton. Okay. We have two types of amphoteric, compound and amphoteric ions. Amphoteric ions. It's first type, this is second type. Amphoteric compounds, we have three amphoteric compounds. CrOH by 3 called chromium hydroxide, chromium trihydroxide, aluminum hydroxide, and water. Water is molecular compound. and these are ionic compounds. Okay? So amphoteric compound or amphoteric property is a property. If we see this property in anything, that means that thing can act as acidic and as basic, both of them. But it depends on the type of reaction. Well, we have two types of amphoteric compound and amphoteric ions. Amphoteric compound, we have three only: CrOH by 3, AlOH by 3, H2O. H2O is molecular compound and they are ionic compound. Chromium trihydroxide, okay, look, I'll show you the name. Chromium hydroxide. It's aluminum hydroxide. Well, about amphoteric anions, it means they are negatively charged. And they must contain a proton, at least one. Amphoteric ion, it holds negative charge. Look, let's see, negative charge. Amphoteric compound, you have three: CrOH by 3, AlOH by 3, H2O, and the second type is amphoteric ion. Okay, they hold negative charge and they must contain a proton, at least one. Doesn't matter that it has one or two protons. Okay. You see, they are amphoteric ion and they are amphoteric compound. I'll show you again. Amphoteric, we have two types of amphoteric. Amphoteric ion and amphoteric compound. Amphoteric compound, we have three: H2O, CrOH by 3, and AlOH by 3. These are ionic compounds. And it's molecular compound. Well, about amphoteric ions, okay, for example, HS, negative. They have negative charge with proton. Another one, H2PO4 negative. Another one, HCO3 negative. Another one, HPO4 negative 2, etc. They are amphoteric ion. Because of their ion, they hold negative charge with at least they have one proton in their formula. And amphoteric compound, you have 3, 1, 2, 3. These are ionic compound. It's molecular compound. Okay, let's get back to the pamphlet. Well, all of them are amphoteric. They are amphoteric. Out of the reaction. It means if we have them out of reaction, they act as an amphoteric. But if we have them in a reaction, they become base or acid. Let's see. Hydrogen bicarbonate, HCO3. It's acid. It's what? It's acid or base or amphoteric. You can say that, okay, HCO3 can donate its proton to producing to produce CO3 negative, or it can gain the proton to producing H2CO3. There's no reaction. It's amphoteric. It can gain and it can lose. So it's amphoteric. The right answer. But here, look. Okay. In this reaction, HCO3, we can see it gains the proton. So it's base. Right? It's base. Look. No, this is wrong. It must be OH. Okay, it must be OH. So it's base. Another one. According to Brown's theory, we can see that water is amphoteric. In this reaction, water is base. Here, water is acid. So it can act as acidic and basic, so it's amphoteric. Another one. Water is, well, you can say water, H2O, it can convert to H3O or OH. So it's amphoteric because of it's not in the reaction. Another reaction. In this reaction, the amphoteric one is, look, H2S releases its proton, so it's acid, it's base, okay, it's conjugate base, it's conjugate acid. So because of we have reactions, so there will be no amphoteric, none of them. Because of we have a reaction, so there is no amphoteric. Here, look at here, these are some important reactions. Which of the following is amphoteric? It's ionic amphoteric. It's ionic amphoteric. It's amphoteric compound. It's amphoteric compound. So which of the following is amphoteric? Because of it doesn't identify it, that it's looking for amphoteric ion or amphoteric compound, amphoteric ion or amphoteric compound. So we have to say both of them. But which of the following is amphoteric ion? It means charge. So the right answer is HS. Which one is amphoteric compound? Is H2O. Okay, so the right answer is H2O. Here, the right answer is A. That was amphoteric. And now we have acid rain. Acid rain actually is another thing. Okay? Okay. About the acid rain. Acid rain, first of all, it contains two words. Two words, look, acid and rain. It means we have a rain that is acidic, but not that much acidic. If we taste, we can feel the acidic. We can feel the sour taste. No, it's not true. It's acid for some laboratory data. Okay, it's not that much acidic that if we taste to feel sour taste. No. Okay, acid rain. First of all, because of it contains water, so it's a solution that contains acid compound. We have three acids. If they present in rain, the rain called acid rain. H2SO4, HNO3, H2CO3. Okay, look. It's an acid solution when sulfur trioxide or the other gases such as NO, NO2, CO, CO2 are reacted with water. So I can say sulfur oxides, such as SO2, SO3, and carbon oxides, such as CO, CO2, and nitrogen oxides, such as NO, NO2, N2O3, etc. If we have them as a gas, surely when they raise up to the sky, to the air, especially during the winter, during the rainy season, the rainy weather, when they meet water, they will react with water to producing acidic compound. So sulfur oxides, they produce H2SO4. Carbon oxides, they produce H2CO3. Nitrogen oxides, they produce HNO3. So these are acidic compounds. If you have them in the rain, it's called acid rain. Surely it's a problem for us because of, I'll show you the disadvantage of the acid rain, the problems caused by acid rain. Because, for example, we have if I talk about our city, Erbil, okay? Erbil is surrounded by many petroleum companies. And they release a lot of gases that contains a huge amount of sulfur dioxide and carbon dioxide mainly, okay? When they raise to the air and when they meet the water that present in air, they will react with the water to producing acidic solution. And what happened to that acid? Surely, it comes down over us, okay? And it makes a lot of problems such as corrosion for farmers, okay? For ecosystem, for fish population. Unfortunately, we don't have that much fish population. So, but in conclusion, I can say, actually, we have many disadvantages here, even caused by acid rain, okay? So, look, sulfur oxides with water, they produce H2SO4. Carbon oxides with water, they produce H2CO3. Nitrogen oxides with water, they produce HNO3. So any gas that contains sulfur, carbon, nitrogen, they will dissolve in the water that present in air to producing acid rain. So I'll repeat to you again, please. Any gas that contains sulfur, carbon, nitrogen, they can dissolve in water that present in air to producing acid rain. Only 3 of them. Look, which of the following gases cannot, which of the following gases, look, okay, which of the following cannot dissolve in the water that present in air to producing acid rain? It will dissolve to producing HNO3. It also to producing H2CO3, but oxygen, no. So the right answer is C. What problem caused by acid rain? Okay, acid rain can cause many problems, such as acid rain causing the fish population in some lakes and streams in there, okay? So acid rain causes fish population, many we can see a huge amount of fish that are die because of the acid rain. You can see in the internet there are a lot of videos. Okay, acid rain can erode sedge according to the following reaction, and biodiversity of the ecosystem decrease caused by acid rain. These are some major problems. Actually, I can count more than 10 disadvantage problems by acid rain, but these are 3 of the major problems caused by acid rain. Okay, another thing, hydroxyl group and hydroxide group. Well, OH called hydroxyl and hydroxide. Hydroxide and hydroxyl. For hydroxide is OH negative, but for hydroxyl it's bond OH. Okay, it's in ionic compound. Such as strong base. So OH in ionic compound, strong base called hydroxide, but it's in molecular compound and amphoteric. Called hydroxyl. So molecular compounds containing OH group, okay, and can be acidic or amphoteric. This is due to dissolve in water, splitting the bond between H and O bond. I'll show you how acid contain OH. Even acids, some of the acids are containing OH group, but they can't yield. They can yield OH when we dissolve them in water. Let's see. OH hydroxyl group present in acid and amphoteric compound, but hydroxide produced by a basic compound and water by self-ionization. Okay. Look, here we have H3PO4. If I show you the formula, the structure of if I show you the structure of H3PO4 formula, it will be like this. It contains 3 OH groups, but it doesn't yield OH because the bond here is so strong, so the bond will break from here between O and H to releasing AH. That's why it's acidic, not basic. H2SO4, its structure of H2SO4's formula, it contains 2 OH group. Okay, these OH groups called hydroxyl because of they won't separate from the formula. The bond between H and O will break. This bond will break. This is so strong. The bond here will break to releasing H. That's why they are acidic. But if the bond break here, okay, so it will be basic because of it will release OH. But for the acidic compound, we know they are releasing H plus basic compound, they release OH. Why? Because of suppose that it's basic compound, so the bond will break here to have OH freely. But because of it is a strong bond, that's why the bond between O and H will break to releasing only H, so we call it acidic compound. And now we have a relation between number of oxygen and acidity strength. Look, I'll show you a consequence here. As much as number of oxygen increase, so polarity of OH bond increase, so the bond gets weaker. Bond will be weaker, easy to break, so the acid will be stronger. Because the bond gets weaker, the acid will be stronger. So if number of oxygen increase, polarity is increased, bonds will be weaker, and the acid will be stronger. Okay, if we have these acids, HClO4, HClO3, HClO2, HClO. Okay, look. Which of the following is the strongest acid? You have to say, if number of oxygen increase, polarity of OH bond increase, bond will be weaker, so the acid will be stronger. It has maximum oxygen, so it's more maximum oxygen number, so more polarity of OH bond, so weakest bond, so strongest acid. But about this one, it has minimum, look, minimum oxygen, so minimum OH polarity, so will be strongest bond, and it will be weakest acid. Okay. Maximum oxygen number, strongest acid. Minimum oxygen number, weakest acid. Because of maximum polarity of OH bond, minimum polarity. Strongest bond, weakest bond. As I told you, the bond strength is reversed with the acidic strength. Sorry, I'm not a native speaker. It's so hard for me to rotate my tongue. Because of I have learned my English in a very late age, almost 3 years ago. That's why for me it's so hard to rotate my tongue like a native speaker, and for me it's so easy. Even I can realize my accent, but it doesn't matter, and it's not a problem for me, even for you, I think. Okay, another thing, between the following compounds, this one, this one, this one, we have these compounds with different number of oxygen. It has 2 oxygens, 3 oxygens, and 4 oxygens. Which one is the strongest acid? Surely that one, because of it contains maximum number of oxygen, maximum OH polarity, weakest bond. It's minimum oxygen number, minimum OH bond polarity, strongest bond. Why, if number of oxygen increase, the polarity increase? Because of oxygen is the second most electronegative in the periodic table. So when number of oxygen increase, it attracts the electron density to itself, so there will be more positivity and negativity. I mean, there will be more polar poles. That's why water can break down the bond easily. Well, I have answered these questions, so I'll start from the neutralization. It needs an individual lecture, and I have to explain neutralization in a very deep detail. Until next time, inshallah, I'll see you again. هیوادارم سوتان لێبینی بێتاو کات بەخواتان دەست پێرم هەر شاد و سەرفراز بن خواتان لەگەڵ.